Yes, hi. Hi everyone. Good morning. Yeah. So I have shared the assignment with you on your drive. So this will be your assignment, and in that you can read just a minute. Not it's not full. Okay, let me add the word file then. I don't have. Not there. Yeah, so basically what you have to do is I need to install this word because it is restricted to this limit only. I am not sure about this, how we can change. So your problem statement is there's one bike sharing company which offers in which bikes are made available for shared, which is used to individual on a short term basis for price or free. Many bike share system allows people to borrow bike from dock, which is usually computer controlled, wherein the user enters the payment information and the system unlocks it. So you have to create a machine learning model and you have to solve these questions. I am uploading these questions drive, on your drive. So anyway, if that file is not visible for you, you just need to build a model and you have to understand the you have to understand the problem statement. It is already there. It is already given there on your drive. And I'll upload the questions as well. Q&A. Ah, this one, I think. So these are the questions for you that you need to solve, right? But here answer is, anyway, that is fine. Okay. So these are the questions that you need to read as well. Like for first of all, the example is from your analysis of your categorical variable from the dataset, what could you infer about their effect on the dependent variable? You have to do the analysis, and this is your answer. So I have already given you answers about that, but you have to build a model, linear regression model on this data. right? Day one CSV. And you'll be able to see your problem statement over here, right? So that is what we have. If I just select this here, and if I just save this, then if I add this here, 940 perfect, will be plus. Okay. Now, if you just check this, you'll be able to get the uh, questions, right? Now, left hand side is remaining. Okay. That we need to take care. Okay. Let us take this. I'll just save this. And let us try to upload this now. So that is your questions. You need to solve this, right? You can take your time, 5 days, 10 days, but it's very interesting. You just need to give it a try. Yeah, now it is looking good. These are the problem statement. This is data preparation, model building, submissions expected. What you need to do is, apart from Python notebook, you also need to answer some subjective questions related to linear regression, which can be downloaded from the file below. I am uploading the PDF file that you need to answer. So that is your subjective questions. I'll just download that and I'll make it available for you. Okay. So I'm uploading the subjective questions as well. You need to answer that subjective questions. Right? Okay. So these are the question series that we are going to have. This is the question series. So these are the assignment based questions and these are the general questions, right? I already have given answers to this over here, question and answer here, but you can give it a try and you can solve that, right? Now, now today, uh, what we are going to do is we are going to start another machine learning model, which is your, yeah, what was the last part that we have studied, guys? Logistic regression. Is it completed or it's remaining? Was it completed? Logistic regression? Yes, everyone. The last session, what did we study? Multivariate logistic regression. And is it completed or not? We were doing a question. Which question? Telecom John case study. Okay. But here, isn't it completed? Just let me check. We have completed till this point. And we can, okay, okay, okay. Model building we are going to do, right? And here we can see that please data cast to numpy data type of object. Please check with npy array. So binomial it was not happening. Okay. Now, in order to do next thing, uh, how do we evaluate the model in classification? We are going to see that. So basically, your regression has target variable as a numeric target variable, and classification has categorical target variable. So if you are working on a classification problem statement, what will be your evaluation metrics? We are going to see that. What are the different evaluation metrics that we have? So what we'll do now is we'll just take out this theoretical part, our discussion, and we'll start working on that. So it's very important to just evaluate your logistic regression model. We have completed this, right? We have completed this. Now here itself, I'm giving heading as 21st December 2024. I'll just take 15, bold, this one. And we'll just put agenda. So the agenda is model evaluation of multivariate logistic regression. Okay. So in this session, we will first learn about few more metrics beyond accuracy that are essential to evaluate the performance of a logistic regression model. Then based on these metrics, you learn how to find out the optimal scenarios where the model will perform the best. The metrics that you learn about are very interesting topic: accuracy, sensitivity, specificity, the receiver operating curve, ROC curve, and precision and recall. So in your linear regression or in your regression models, the evaluation metrics that we have seen are R to score, accuracy, isn't it? Or mean squared error. The cost function are like that, right? Here, your cost function or your evaluation metrics are different. It is this. So firstly, once you have chosen the optimal scenario based on the evaluation metrics, you'll finally go on and make predictions on the test data set and see how your model performs there. And uh, we will see why accuracy is alone not sufficient to give us an idea about the performance of the uh, classification model, performance of your classification model, right? So we'll just take one scenario where accuracy gives us the bad idea about that. So in order to take this, we should, okay, we can take one example. Let's say, just a minute. Okay, let's take this. So we'll just see how accuracy alone is not sufficient to give us an idea about the performance of your classification model. So what we'll do is we'll take a scenario where accuracy fails, right? So suppose you are interested to predict whether whether customer has a disease or not, a disease or not, right? So you have done everything. You have calculated accuracy score, and accuracy suppose you are getting is 96%, right? So here we plot very important term which is known as confusion matrix. Confusion matrix. We'll just see about that. What is confusion matrix? We'll see more details about that. So what confusion matrix is, uh, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, or let's take this. This is your confusion matrix. In that, the above, this one represents the actual values. This one represents the actual values. So these are the positive, these are the negative. These are the positive, these are the negative. And this represents predicted values, right? So this represents predicted value, this represents actual values. And we are taking the same example where we are predicting customer, not customer, patient has disease or not. So suppose you have this data where your actual value is yes, person has disease. Predicted value is also yes, person has disease. Actual is yes, predicted is no. Actual is no, predicted is yes. Actual is no, predicted is no. There can be four possible scenario maximum. Yes or no? So actually is yes, predicted is yes. Is it correct prediction? In this, out of this four prediction, which one is correct or which one are correct? Can you just guess? 1, 2, 3, 4. We have four predictions. Which one is correct out of those? Yes, guys?
1 and 3.
Yeah?
1 and 3.
1 and 3. Is it 3 or 4?
This one. 3 means the number 3. Yeah, this. Yeah.
Is it correct or is it incorrect?
But it's incorrect. But actual value correct is 1 and 2. But the predicted value corrected is 1 and 3.
No, no, no. What I'm saying is this is entire one. Consider this entire one bucket. Your actual value was yes. Model has predicted yes. So it is correct. Right? Actual value it was yes,
Yeah.
but model
Yeah,
said
then
no.
only one is correct.
And what about 4?
4 are not correct.
It is correct. No, 4 is also correct.
Yes,
Actual value was
4. Yes, 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 yes.
right. And out of this two, these are incorrect. So we can say error. And this is also error. Right? Now let us try to understand the confusion matrix. It is same. What we are doing is we are just trying to fit a box. Actual is positive, predicted is positive. So this is correct prediction. So this is known as true positive. Actual is negative, model has predicted positive. So this is false positive. This is actual is positive, model has predicted negative. So this is false and this is negative. And actually it is negative, model has predicted negative. So this is also known as true negative. So true positive and true negative are correct. So I can give green color for this. And false positive is error, false negative is error. Yes or no? So what we do is we call a package from sklearn.metrics. We import confusion metrics. We import confusion metrics, and it will directly give us these values. So suppose you have calculated the confusion matrix, and the confusion matrix values that you have are this 50, sorry, 560, 60, 50, and 330. And you know, out of this, two are correct. Out of this, two are correct. And out of this, these are wrong. This one, and this one are wrong. Right? So that's what we have. Simple. So I got to know that this 60 and 50 are incorrectly labeled, right? Incorrectly labeled, and I want to increase my accuracy. So what is your accuracy formula is? What's your accuracy formula is? It is correct prediction, correct prediction divided by total number of predictions, right? Your accuracy formula is correct prediction divided by uh, incorrect prediction. So it will be is equals to 560 plus uh, 330. These are the correct predictions, right? Divided by all, everything. 560 plus 60 plus 50 plus 330. I have not done this. Okay. So it is 0.89. So that is how you get the accuracy, right? By just using the coding part. So 89% is your accuracy. Yes. And you are in the notion that you got 89% accuracy, and you can say that you can predict the 86% 86% sick people, or you can predict sick people 86% or 89, rather 89% of the time, right? But however, it is doing the opposite. Accuracy, what it does is it gives an idea about this. It predicts the people who will not get sick with 89% of the time, or 89% of the accuracy. But while uh, we were interested to predict how many customers, or how many, what's the accuracy of predicting, or you are interested to predict what will be your accuracy to uh, predict patient sick. You are interested to predict this, but you are getting this accuracy that who will not get sick, right? So it is not our correct measure. We are interested to predict the person who will be sick, but it will give you a probability of person who will not get sick. Are you guys getting this point? So it is not a correct measure, right? So for an example, there is one critical virus. Let's say, let's change the problem statement. We are interested to predict the patient having coronavirus, let's say, or not. So we are interested to predict how many customers, how many patient are infected with the virus, but it is giving us an idea about how many person, or how what's the total amount of patient who will not be having virus. So it is not considering the person who has virus. Yes or not? That's why we have some different measures. So that's why they have introduced precision. What precision will give you? It tells you how many of the correctly predicted cases actually turned out to be positive. You have predicted the cases. Out of them, how many turn out to be positive? So it is divided by true positive plus false positive. Because your model has predicted positive, so you just have to consider out of this positive are this, right? Model has predicted positive. These two are the case, right? This one is positive. This one is positive predicted by your model. Out of those, how many only turn out to be positive? So true positive is the one which is turned out to be positive, and total positive are true positive plus false positive. Simple. So TP plus F. And if you just calculate that by using this formula, so it is 560 divided by 620, right? Is equals to, I'll write on 560 divided by 560 plus 60. So it is 0.90, 90.32% is the precision. And what do you mean by precision? I only have discussed just now. What is precision? We'll discuss this. Kamar, you have to communicate with me. What is precision? Yes, guys. What is precision? You can read this line.
Predicted cases, how many are the correct cases?
Yes,
In all predicted cases, how many are the correct? How many are?
very good. So, uh, just a minute. Yeah. So it gives you how many of the correctly predicted cases actually turn out to be positive. Recall will give you how many of the actual positive cases we were able to predict correctly with our model. Now let us try to understand recall. What is recall? It tells us how many of the actual positive cases we were able to predict. We were able to predict correctly with our model. How many of the actual positive cases we were able to predict correctly. So actual positive, how many we were having actual positive? This one, true positive and false positive. These were the actual positive, right? And we were only able to predict true positive. This has to be positive. We have failed to predict this as positive, but it was actual positive, model has predicted negative. So it is true positive. It is true positive divided by true positive plus false negative. So I'll write down this. It is 560 divided by 560 plus 50. 560 plus 50. So it is 91.8%. So we can say that my recall is 91%. And I can say 91, rather 91 point, not 91, 91.8%, 91.8% of the positive cases which were actually positive were successfully predicted by our model. Successfully predicted by our model. So it is good, right? The recall should be as maximum as possible, right? And what about precision? What about precision? I can say out of this 90.32%, 90.32% of the correctly predicted cases turned out to be positive. Turned out to be positive, right? Out of 100%, 90.32% of the correctly predicted cases turn out to be positive. That was the case. So these two uh, metrics, it has to be as maximum as possible, right? Precision should be maximum, recall should be maximum. So we'll just see a scenario where precision is helpful for us, where we should consider precision. We should consider precision, where it is a useful metric where the false positive is a higher concern, than false negative, than false negatives. And recall is a useful metric in cases where false negative trumps false positive. Means false negative is a higher concern. False negative is a higher concern. Now we'll see a scenario. Very, very interesting. We'll see a scenario where precision is important. We'll see a scenario where recall is important. Now see, we have music and video recommendation, right? In music and video recommendation or e-commerce website, your wrong result, your wrong result can lead to customer churn. They will leave your network or they will not choose your service, and it will be harmful for your business, right? So out of this positive predicted, how many are correctly predicted will give an idea. Precision will give you an idea about that. Out of this correctly predicted, positive predicted, how many are positive, right? How many are positive? So even though this is not correct, this false positive is not correct prediction, we are not worried about that. We are worried about how many of the positive predicted, how many are the correctly predicted, right? Out of positive predicted, how many are the correct predicted? So precision is important in that scenario where the customer who is positive, I mean, who is out of the positive predicted, this one is correct, and we are interested to target this. So that is your scenario. And recall is useful metric where in medical cases, right? In medical cases, false negative is important for you. How false negative is important for you? Let's say we'll just try to understand the significance of each and every term. What is true positive? What is false positive? Then you'll understand. See, let us take this scenario wherein we are interested to predict whether patient is sick or not, or patient has the disease or not. So this true positive, what is this true positive? Actual is positive, predicted is positive. So I can say true positive as sick people, correctly predicted as sick by the model. Yes or no? Then we have false positive. What is false positive? Healthy people, healthy people, incorrectly predicted, incorrectly predicted as sick by the model. Sick by the model. We have false negative, false negative. Sick people incorrectly predicted as not sick by the model. Simple. And what is true negative? It is healthy people. The people we are predicting, we are targeting are were healthy, but they are correctly predicted as not sick by the model, right? Simple. Now, in medical scenario, where false negative is very important for us, like sick people incorrectly predicted as not sick. They were sick, right? They were in the critical situation, and we should predict them as sick because they are critical. They are in, let's say we are talking about cancer. Let's say this is cancer patient, right? And where the situation is so critical that they are sick, and we should not be able to neglect them. We should not be able to neglect them because there will be chance of death. Yes or no? So where false negative is higher concern, we should go with the recall. That is your medical cases. Yes or no? So it doesn't matter for me whether we raise false alarm. False alarm in the sense, uh, actual, actually, actual positive cases should not go undetected. Undetected means person having disease, they should not go undetected. Detected, right? It will fine. Let's say it is fine for me if I just raise a false alarm. Means people they were healthy, but we incorrectly predicted them as sick. Right? We incorrectly predict them as sick. So that is fine for me. Let's say we are interested to raise an alarm, and I have raised an alarm for healthy people, healthy person, but for a sick. Means I have raised an alarm that, let's say there is one person ABC who is healthy, but I have marked this person as unhealthy, right? Because anyway, if we check this again and this is just a model, right? Model has predicted this person, or doctor will physically check this person and we can conclude that this is healthy. But we should not miss that person. We should not miss that person who is unhealthy, and we have marked them as healthy, right? That is a false negative. So recall is important in that case. Precision is important in false positive case. What is false positive? Healthy people are incorrectly predicted as sick by the model. So let us consider this music recommendation system. They were interested, right? These people were interested in your company, in your application, in your Spotify, let's say, or in your YouTube uh, uh, recommendation app. But you incorrectly predicted them as not interested. So that's your loss for your model, yes or no? Loss for your business. False positive is this person, they were interested, but you you mark them as not interested. That is a false positive case. So I hope you got a clear cut idea about when precision is important, when recall is important, and when accuracy fails. And we have last metric, that is your F1 score. F1 score. We have last metric, that is your F1 score. It's a harmonic mean. It's a harmonic mean of precision and recall. It's a harmonic mean of precision and recall. So it gives a combined idea about these two metrics, right? Harmonic mean means it is 2 times precision, 2 times precision into recall divided by precision plus recall. 2 times precision into recall divided by precision plus recall. That's your harmonic mean, right? So that's all about your precision and recall and your confusion matrix. You go through this will be your very, very important part. You go through this, I'll give you 5 minutes of time. And once you are done with this, we'll see how to calculate confusion matrix by using Python. We'll see that. So it's 9:48. Take your time till 9:55, I'll say. We will be starting with the coding part, right? Go through this one more time, everyone. Okay, so that's what we have for the evaluation matrix for classification, right? Now, what we'll do is we will try to find the confusion matrix. How do you calculate the confusion matrix? We'll just try to see that. So just give me a minute. I'll be sharing my screen. Just a minute. Yes. So we will require to upload, we'll need to upload data, we'll require to upload data. We will just upload data first. The data for this is uh, four data: churn data, customer data, and internet data. Okay. So I'll just upload that. Internet data, this one. Click on OK. Then we have customer data. So I'll just upload customer data. Then we have churn data, right? So we'll take this, upload this, and I think only three. Okay. So if I just restart and run all this, I will be able to get this thing. And now what we are interested to do is we are interested to find the confusion matrix. We're interested to go with the confusion matrix. This will, we are getting error for this. Now we'll get error for this anyway. We'll evaluate the model in classification. We'll evaluate the model in classification. So stats model library is fine, but we'll go with the sklearn because, excuse me, sklearn library is used by machine learning engineer and stats model library is used by the uh, what we can say statistician, right? So I'll just write down from sklearn dot metrics. Anyway, you guys will not be using stats model library, so you don't need to worry about this. We will predominantly use sklearn. In that, from sklearn.metrics, we are going to import confusion matrix and classification report. And I'm just interested to check the confusion matrix. So I'll write on confusion is equals to metrics dot confusion matrix y test and y parade. And I'm going to print the confusion matrix. Matrix. Okay. We should not write down this because we have already imported confusion matrix. So directly we can write down confusion matrix. Y parade is not defined for us. Is that the case? What we have defined is y underscore. Just what we have defined is y underscore y train parade. Okay, y train parade. Confusion matrix of y train parade. So y underscore train underscore parade. We have not defined that. Oh, is it? We need to do that, no? Okay. All right. So what we'll do is we will first of all uh, calculate the Y train spread. For that, we need to perform the stats model library. We need to check the stats model x underscore train. This is fine. I am not interested to do this, so I'll close this log1 m dot fit summary, but we are not getting this output. RFE. Let's say if I just go for a recursive feature elimination, RFE. So I'll return from sklearn dot feature underscore selection. We are going to import RFE, recursive feature elimination. RFE is equals to the package logistic regression, comma 15 features I want, right? 15 any random features, and I'll just fit it on external y-train. Log reg not defined. Logren, yeah, we have to define an object for that. So what we'll do is we'll call out an package from sklearn dot linear underscore model, linear underscore model. We are going to import logistic regression, logistic regression, and log reg is equals to logistic regression, open and close bracket. Sklearn. Perfect. Now we can feed this RFE in a text2 argument. Okay. Same error we are getting for this RFE. In that it says we it should have two positional argument. We are passing three, but anyway we are passing only two over there. So I think we should move with the uh, collab. We should go with the Jupyter notebook in order to resolve this error. See, if I just pass one, it will say you should pass two, right? And if I just pass another argument, we have only logic regression and 15. We have two parameters, but it throws the error. So in Colab, there is one problem associated with RFE that we also have discussed previously, right? So that's the reason it is not able to give us the output. Anyway, what we can do is we will shift towards the, I'll just download this and we'll go to Jupyter now. So I hope you guys got an idea about this. It's very simple. You just need to import a package confusion matrix, and you just call out that by using ytrain pred. You'll get a confusion matrix like this. Just a minute. You'll get a confusion matrix like this, and you can calculate precision and recall by using a package. So for precision and recall as well, if I just search how do we calculate precision, how do we calculate recall, precision, recall, sklearn, official documentation. If you just see this, it's very simple. You just need to import a package for that. From sklearn.metrics, precision score. So suppose this is your data. You want to calculate precision score for this. You will be calculating that by using don't need to go about this micro level calculation. Precision score, yeah. This one. Yeah. So we'll import from sklearn.metrics, we'll import precision score. We'll find precision score between y true, y y actual and y pred, and you'll get the precision score. Suppose you want to calculate recall, so you'll import recall package and you'll calculate that. Now let us try to do this over here. Multivariate logistic regression, this one. So I'll just upload that particular file, which is this. And just take this. We'll just take this. We'll paste it over here. Let us restart and run all this. Let us paste it over here. And we'll just take this. We'll paste it over here. Number of features to select is equals to 15. Okay. In RFE, you are saying, suppose if I just if I just take this number of features to select, okay, I need to pass this one is equals to 15. It's not working. It says input X contains null values. Do not accept missing values. We have to remove that. And what about he? Let's say this. If I just run this, X string is not defined. This is old notebook. This is new. Mhm. This is working. Okay, we need to treat the null values. Did we not remove the null values earlier? Feature scaling, print test split is done. Before that, we have done percentage of missing values. We have checked that, right? It is in cell number before this outliers. Not done. After outliers, we have done that. So that's the reason. Okay. Okay, let us drop the uh, missing values. Let us drop the missing values. So, but we don't have any missing values. We have checked that, right? We don't have any missing values. So why it says that we have missing value? We have already checked, right? We don't have any missing value. We don't have any null records. Let's check for total charges. In this data, telecom, for total charges column, I need to check, do I have any null records or not? Here it says I have 11 null records. Then why it does not? Okay, now it is saying. Got it. So we have to treat this, right? We have to remove this null value. That's why it was not uh, uh, taking, right? So I'll write down telecom is equals to telecom data of this np.isNan. So I am removing null values by using negation approach, right? We already have discussed this. So total charges column, and I'll just close this. And then if I just simply check null values in this, I will not be having null records. Perfect. Now if I just try to fit this, let us try to fit this RFA. And what does it says? It says null value or a value too large for data type float 64. Okay, we have float 64. That is too large. Let us check the data type. Telecom.info. Float 64 is for monthly charges and total charges. We need to convert that into integer. If I just check head of the data, head. By checking the head of the data, we get to know monthly charges and total charges are the float value, right? So we need to take care of that. So either we can convert that to integer, or we have done this for other column earlier. PD.2 numeric. Where is that? Here. For total charges, we already have done. Let us try to convert that to integer. Let's try to do that. Let's type integer. So in my data, I just want to convert charges in INR, not charges in INR. What is that column name? Charges, total charges and monthly charges. Okay. So I'll just try this. I'll paste it over here. I'll take help of this. Here we should do it earlier before train test split, where we have converted data type, where we have converted that. Here, right? Before train test split, we should do that. So telecom of, let's say, total charges, this one. So Control C, Control V is equals to telecom of total charges, and I'm interested to change the data type by using this dot as type integer 64 dot as type integer 64. If I just run this, it is done. And we will do this same for charges, the other column, monthly charges. So the data column name is this, monthly charges. So I'll copy that, I'll paste it over here, I'll copy this, I'll paste it over here, right? It's done now. And then I'll need to restart this, everything, and then we'll see if it is happening or not. Let's see. So sometimes what happens is if data is not proper, it's not in proper format, it takes this much time. You have to go back, change the data type. You have to go back, change the data type from float to integer, and then you will be able to see that it is working fine, right? So you have to learn from the error itself. And now um, if I just uh, find the confusion matrix, here before confusion matrix, we have to do something, right? That was missing, that we are interested to do after RFE. After RFE, why train parade is not defined, right? Just a minute. So we need to, RFE is done. RFE is done. We'll write down RFE underscore support underscore RFE dot support underscore. And then we'll make a list of all the columns that we have selected, or our model RFE has selected uh, by using x underscore train dot columns, x underscore train dot columns.
Isn't it X underscore train, sir?
Oh, my bad. Yeah. So these are the columns that we have selected. Now we will convert this into COL variable. Column is equals to x underscore train dot columns of RFE dot support underscore, and no attribute support. Support spelling is wrong. And we will just define a variable x underscore train dot columns of negation RFE dot support underscore. And let us try to assess the model with stats models. So we'll write down x underscore train underscore sm is equals to sm dot add underscore constant, and that will pass x underscore train and what we need to do is x underscore train of column, and then we'll write on logistic regression model 2 let's say is equals to sm dot glm of y underscore train, comma x underscore train, underscore sm, comma family is equals to sm dot families dot binomial, close bracket. And then we'll write a residual is equals to logistic regression model 2 will fit that, and we'll write on residual dot summary, close bracket. Yeah, it's done now. I think earlier one where we have fitted the logistic regression model this, uh, it will also work fine. And this, see, can you see this? Here we are getting the output. Earlier we were not getting the output for this because of the null values and the improper data type format. So you got a lesson over here like that. Even though if you have checked the null values, there might be null values in the record, first point. Second point is you have to check the data type. You have to learn from the error. It says the value is too large to handle, meaning that float value, large float value, it will not handle. You have to change that to integer by using as type function, right? So there might be a chance that you are doing good and you are writing code in proper format. Still, you guys will be able to, you guys will face some error, and that you need to resolve by just copying that particular error, just having look at Stack Overflow website, or you can take help of your technical skill set. As I was already aware about this as type function, I use that, and you can also do the same, right? That's the reason we were getting there, and you got an understanding. You got an understanding of what, how we should proceed further if we get the live error, right? Now let us move towards the next part. We have to define y trend pair. That's why we are doing this thing. Um, so getting the predicted values on the train set, we'll write on y underscore train underscore parade underscore parade is equals to residual that we have defined dot predict underscore x underscore train x underscore train underscore sm and y underscore train underscore parade is equals to of 0 to 10, right? Now we'll just reshape this y underscore train underscore parade is equals to y underscore train underscore parade dot values dot reshape of -1, and we'll write in y underscore train underscore parade underscore parade of 0 to 10, right? And then we'll create a data frame with the actual churn flag. Let us give heading as creating a data frame with the actual churn flag and the predicted probabilities. So we'll write on y underscore train underscore parade underscore final is equals to pd dot data frame churn. We are creating a column churn. In that we are going to pass y underscore train and dot values, comma churn underscore probability of y underscore train underscore parade and y underscore train underscore parade underscore final of customer ID is equals to y underscore train dot index and y underscore train underscore parade underscore final dot head open and close bracket, right? Then we'll create a new column. We'll create a new column that is predicted with 1 if churn underscore probability is greater than 0.5, else we'll write on 0. We'll write on y underscore train y underscore train underscore parade underscore final of predicted is equals to y underscore train underscore parade underscore final dot churn dot underscore probability dot map of lambda x of 1 if x is greater than 0.5, otherwise it should be 0. And let us see the head. So let n y underscore train underscore parade underscore final dot head open and close bracket. So these are the churn probability. And now it's time to call the metrics, this one. So confusion metrics will just plot between y trade final dot churn and y underscore train underscore parade underscore final dot predicted. Then we'll just print confusion. Now, what is your understanding from this? Chalo, who will discuss this with me? What is your understanding from this confusion matrix? Very good. With this, we can find TP, FP, TN, FN, NFN values. Very good. What about other guys? What else? This is a very basic question. And you have to give answer accordingly, like this. First point is we'll be able to find the TPFP. Second point is we'll be able to find accuracy. Third point is we'll be able to find precision. We'll be able to find recall. And in this case, whether we are predicting if the customer will churn the mobile network or not, which one is important over here? Which metrics is important? Whether it's precision or recall, which is important? Yes, guys. Which one is important for us? Well, precision, very good. So we should calculate the precision. We should find the precision. It should be as high as possible, right? So before this, we'll just check the accuracy score. Even though accuracy will misguide you, uh, it is not the correct measure to find that. It will misguide you. So that should not be only metrics that we should use, right? Then we'll write on y underscore train underscore parade underscore final dot predicted. This is accuracy score is not defined. Okay. In this, we need to calculate, you need to import accuracy score as well as a metric. Accuracy underscore score. So it is 80.61, right? Now we need to check the BIF score. BIF. So from stats models dot stats dot outliers underscore influence, I'm going to import variance inflation factor, right? And I'm going to create a data frame that will contain the names of all the feature variables and their respective VIFs. So we'll write down VIF is equals to PD dot data frame, open and close bracket. VIF is VIF of features, creating a column. In that we are going to pass x underscore train of column dot columns. We'll pass VIF of VIF is equals to variance inflation factor, and we'll pass x underscore train of column dot values comma I for I in range of x underscore train of column dot shape of 1, and then VIF of VIF is equals to round of VIF of VIF comma 2. VIF is equals to VIF dot sort underscore values. We want to sort this by VIF column, and comma ascending is equals to false. Then we'll check what is there in VIF. Now we got to know that monthly charges is having highest VIF, and we need to deal with that. Yes or no? We should drop this column which is having VIF greater than 5. So how to deal with this? How do we drop this VIF column? So what we will do is we can drop this. I'll leave this topic up to you. You guys need to, you can drop these variables. I'll just give you one demo, like how you can proceed further is you can drop the phone services. So you'll create column is equals to, let's say you want to drop monthly charges column. So you'll do that. You'll write down column dot drop phone service or monthly charges comma 1, column is equals to this, and let's rerun the model using the selected variables. I'll write down x underscore train underscore sm is equals to sm dot add underscore constant x underscore train of column. Now logistic regression model number 3. You can do the same thing which we have done, sm dot glm y underscore train comma x underscore train underscore sm comma comma family is equals to sm dot families dot binomial open and close bracket, residual is equals to log m3 dot fit open and close bracket, residual dot summary open and close. That's what we have, right? Now we'll write down y underscore train underscore braid is equals to residual dot predict x underscore train underscore sm dot values dot reshape minus 1. We'll write on y underscore train underscore braid of 0 to 10, and we'll write on y underscore train underscore braid underscore final. We are interested to find churn probability. Churn underscore probability is equals to y underscore train underscore predict, and we'll create a new column predicted with 1 if churn probability is greater than 0.5, else it is 0. So we'll write on y underscore train underscore parade underscore final. In that, we'll create new column predicted. That should be exactly equals to y underscore train underscore parade underscore final dot churn underscore probability. We'll map this with lambda x of 1 if your x probability is greater than 0, 0.5, right? So we have seen sigmoid function. We are setting a threshold. If my probability is greater than 0.5, I'll classify them as label 1. Classify them as label 1. If it is less than 0.5, I'll classify them as label 2 or class 0. And class 0 is your, this is churning probability, right? If churn probability is less than 0.5, means customer will not churn, right? And if the churn probability is greater than 0.5, it means that customer will churn. Simple. So that's what we are doing, setting a threshold as 0.5. And we'll write down y underscore train underscore parade underscore final dot head open and close bracket. And now let us check let us check the overall accuracy. So I'm going to print metrics dot accuracy score. Here we only need to write down accuracy score. Accuracy underscore score between the same thing which we have done earlier. So you can take a leverage of copying this code directly, because copy and paste is allowed here so that it saves our time. So it is 80.55, right? The reason why we are not getting significant increase in the accuracy, because we have not dropped these features: internet service, total charges, internet service no, tenure. This should be dropped, right? So I already have told you, I have left this topic up to you. You have to drop multiple variables. I have just given you how do you drop one variable. You have to drop the multiple variables. Will you be able to do that, everyone? Okay. So just give me a minute. So you can do this, right? And you can increase your accuracy. Now it's time to find the it's time to check the metrics beyond simply accuracy. TP is equals to confusion matrix. With that, I want to find 1, 1. That is my true positive rate, right? What is your true positive rate? Where 1, 1. Let's call positive as 1 and negative as 0. So true positive is nothing but 1, 1. So in this confusion matrix that we have calculated earlier, in our confusion matrix, this one, I am interested to find the true positive rate. And what is my true positive rate? Where both the columns are 1, 1, right? What about true negative? So who will help me out with this true negative confusion matrix of it is? What about false positive? Confusion. And what about false negative? Confusion. False negative is True negative is 0, 0. Very good. Excellent. What about false positive? False positive is 1, 0. No, the first one is related to your actual value. So 1, 1. Then first one is related to actual, no? True negative is 0, 0. Right? Now here, what we are finding is false positive. So false first is actual, no? So that should be 0. Second one is predicted. So that should be 1. Right? So the convention that we are following is first is for actual, second is for predicted. 0, 1, 1, 0. Right? So let's see the sensitivity of our logistic regression model. So TP, you don't need to do this because this is just a manual calculation, right? We have a package for that. Sensitivity and specificity. We have not seen this. We'll see that. So let us calculate the specificity. That is true negative divided by float of true negative plus false positive. The sensitivity is okay, we'll just find this first and we'll see this. Then I am interested to calculate false positive rate. False positive rate, that is predicting churn when customer does not have churn. Right? False positive rate means predicting churn when customer does not have churn. Right? So that is my false positive divided by float of true negative plus false positive. That is 0.10. And what about positive predicted values? That is your precision. True positive divided by true positive plus false positive. So we'll write down TP divided by float of TP plus FP. Right? Now it's time to go for negative predicting value. We'll write down true negative divided by float of true negative plus false negative. That is a 0.8477. Now it's time to plot the ROC curve. We will also see this ROC curve and I will discuss what is specificity, what is sensitivity, what is true positive rate, and what is false positive rate. But let us first plot the ROC curve. So I'll put a heading as step number 9 or whatever it may be. Heading is plotting the ROC curve, and an ROC curve demonstrates several things. It shows the trade-off between sensitivity and specificity. Any increase will be accompanied by a decrease in specificity. And the closer the curve follows the left hand border, and then the top border of the ROC space, the more accurate the test. And the closer the curve becomes comes to the 45-degree diagonal of the ROC space, the less accurate the test is. So I'll define ROC curve, draw underscore ROC. In that, I'm going to pass actual, comma problems is this. I'll write an FPR, comma true positive rate, comma thresholds is equals to matrix dot ROC underscore curve actual, comma props, comma drop underscore intermediate is equals to false. I'll return AUC underscore score is equals to matrix dot ROC underscore AUC underscore score. In that, I want actual minus probabilities props. And I will plot the figure, PLT dot figure. In that, I'm setting a figure size is equals to 5, 5. PLT dot plot false positive rate, true positive rate. Label of this plot is ROC curve. ROC curve area is equals to percentage 0.2f percentage AUC underscore score PLT dot plot 0, 1, 0, 1, comma a dash dash PLT dot x line 0.0, 1.0 PLT dot y 11 0.0, 1.05 PLT dot x label is false positive rate or 1 minus true negative rate. Return PLT dot y label is true positive rate. And write down PLT dot title as receiver operating characteristics example. Receiver operating characteristics example. Okay. And then I'll write down PLT dot lesion. In that LOC is equals to lower right. And I'll write down PLT dot show open and close bracket. And then I'll return none. Simple. Right? So FPR, comma TPR, comma thresholds is equals to matrix dot ROC underscore curve between y underscore train underscore parade underscore final dot churn comma y underscore train underscore parade underscore final dot churn underscore probability comma drop underscore intermediate is equals to false. You don't need to worry about this code, guys, because nobody will ask you to draw ROC curve. But I am just explaining you how this receiver operating curve is calculated, and from that how we generally get an understanding of how good model is. ROC curve is not defined, we need to import a package for that. Suppose I don't know the ROC curve package. I'll go to official documentation from sklearn and I'll just plot this ROC curve. So from sklearn import matrix, this is also fine. And in that you can call this ROC underscore curve. Let us check. Let us see from how do you call this from sklearn dot matrix. I'm going to import ROC underscore curve package. It is done. Now if I just call this, it will be calculated. And I am interested to find the receiver operating curve for this churn underscore probability. This matrix is not defined where we have done matrix. I think it's earlier here. So that is also fine. No problem for that. ROC-AUC score. ROC-AUC. Where is ROC-AUC? Okay. This one is something which we need to import. Now, actual value is wrong. Spelling is wrong. Actual. Yeah, this is your receiver operating curve, right? Now, let us discuss these three terms. One is specificity. Second one was sensitivity, right? Sensitivity. And third is true positive rate, false positive rate. Fourth one is ROC curve. Fifth one is area under curve, AUC. Right? So let us try to understand this. Very first thing first. What we have done is we have calculated the yeah. So first thing first, we will understand the concept of sensitivity. So just give me a minute, just a minute. I will we will see this with example. Okay. Let us go to this thing. Uh, yeah, here we can do this. Okay. So we are interested to find the sensitivity and specificity. So let us give heading as what are sensitivity and specificity. Let us put heading as this, bold, and this one. First one, sensitivity tells us what proportion of the positive class got correctly classified. What proportion of the positive class got correctly classified, right? So we'll write on sensitivity VT is equals to true positive divided by true positive plus false negative. So what portion of the positive class got correctly classified? So what portion? Uh, let us take this here. Out of this, how many are positive classes over here? What portion of the positive class? We have true positive and false negative. These are the actual positive, right? Out of this, how many correctly positive? It is true positive. So can I say sensitivity as recall? Can I say this? Yes or no? Can we say sensitivity as recall? Because the formula is same, right? And we already have seen an example for this. The cases, medical cases, right? Now we have specificity. We have specificity. That is nothing but known as true negative rate. The specificity tells us what proportion of the negative class got correctly classified. What portion of the negative class got correctly classified? We have negative class. Out of them, how many are correctly classified? So negative is equals to false positive, true negative, and out of them, correctly classified is true negative divided by true negative plus false positive, right? And taking an example as specificity and sensitivity would mean determining the proportion of healthy people who were correctly identified the model. Then we have false positive rate. We have false positive rate that is known as FPR. FPR will give you, it is 1 minus specificity, simple, right? You calculate specificity and you do 1 minus that. It tells us, false positive will tells us what proportion of the negative class got incorrectly classified by the classifier. So a higher true negative rate TNR and a low false positive rate are desirable since we want to classify the negative class correctly. Since we want to classify the negative class correctly. And out of this matrix, perhaps sensitivity, specificity are most important. And we will see how this are used to build an evaluation metric. But before that, let us understand the ROC and AUC curve. ROC and AUC curve. So before that, it is better to understand probability. Why probability of prediction is better than predicting the target class. Predicting the target class directly, right? Okay, so we'll just have a break for Kahoot now. You guys will be having a quiz, and after the quiz, we will be discussing probability of predictions. This one. So I'll just write down, highlight this. Okay. Okay, let's have quiz now.
Quiz link I have shared in chat box so everyone can join. The Kahoot is done, so you can continue with the session. Thank you.
Yes. Yes, thank you. Now we'll just continue with our discussion that we were having. So we were discussing this, right? The probability of prediction. Just give me a minute. Just a minute, guys. Just you go through this false positive and true positive, right? Just give me a minute. Just allow me a minute. Kindly send drive link. You don't have your drive link? Yes, Chandra Mohan. Don't you have your drive link? Yeah, you go through this. Just allow me a minute. Yeah. So let us understand why probability of prediction is better than predicting the target class directly. So let's consider a machine learning classification model can be used to naturally predict the data points of actual class or predicted class its probability of belonging to the different classes. Employing an AUC ROC curve, for evaluation, the latter give us the more control over the result and we can determine our own threshold to interpret the result of the classifier. A valuable respect when considering the nuances of the ROC curve. This approach is sometimes more important than just building a completely new model. So we set a threshold for classifying positive classes for data points, and it will change the sensitivity, it will change the specificity, and one of the thresholds will probably give a better result. So threshold can be 0.5, threshold can be 0.6, right? And depending on whether we are aiming for lower the number of false negative or lower the number of false positive, we set the threshold. So metrics change when with the changing threshold values. If we can generate different confusion metrics and compare the various metrics that we discussed in the previous section, but that would not be a important thing to do. Instead of that, we can plot ROC curve between some of these metrics to quickly visualize which threshold is giving us the better result. So how does AUC ROC curve work, right? So we'll just take an example of this AUC ROC curve. We'll just take a figure of this rather than example. So suppose this is your example. So AOC ROC curve. In AOC ROC curve, this is very important question. It can be asked in the interviews, or it has been asked multiple times in the interview. On your x-axis, how will you answer what is AOC ROC curve and how it helps you out? On your x-axis, you have false positive rate. On your y-axis, you have true positive rate, right? And so this is known as receiver operating curve, ROC. And AOC nothing but is known as area under curve, which gives us an idea about how good the model is, right? So we can try to and understand this graph by generating a confusion matrix for each point corresponding to the threshold, right? So suppose your area under curve is, let's say, 0.5. Let's say this. So it's a random, any random classifier, any random simple model, right? Its probability of classifying positive and negative classes is 0.5. So at any point of time, your probability should be higher than this at any point of time. Probability should be higher than this. So let's say your area under curve is this. Your receiver operator curve you have plotted, it is coming like this. In our case, in our model, our ROC curve was coming like this, and it is very good because if you just calculate the area under curve, that is your this portion, area under the curve, it will be ideally it should be greater than 50. That is your this one, because this is area under curve, this is 50%, right? Now suppose for this curve, your area under the curve is, let's say, more than 50, let's say 60. So higher the area under the curve, this one, higher the better is the model is, and lower the area under curve, worse the model is, right? So this is tic-tac model, this is but good model, this is better, and this is best, blue one, right? So that is what your significance is, right? Is it clear now what is FPR, TPR, and what is ROC, what is AUC? So the good model has higher area under the curve, right? Ideally, it should be greater than 0.5. On x-axis, you have false positive rate. On y-axis, you have true positive rate. So it's a indicator, it's a measure for your model that how correctly, how accurately, how precisely your model is separating positive classes from negative classes. That's your measure, right? So if you just see significance of this, AUC ROC curve significance, you will be able to see this, that it's a use for evaluation the model's ability to distinguish between positive and negative classes. And it's a single number that summarizes the model performance across all possible classification threshold. So the reason why we calculate this is you can set threshold as 0.5, you can set threshold as 0.7, you can set threshold as, this is your sigmoid curve, as 0.9. So above the 0.9, you'll classify this as class 1. Below the 0.9, you classify this as class 0. And likewise, right? So for each and every threshold out there, you will be having different specificity, different precision, different recall, right? But this AUC ROC curve, it gives you single number that summarizes how the model performance is across all the possible classification threshold. right? All the possible classification threshold. Is it clear now, everyone? Is this thing clear? AOC ROC curve, everyone? Now, what I'll do is quickly, I will upload this file and we'll just discuss a machine learning framework. That is important part for us. So today is being day number 22. Day 22 as 21st December 2024. And I will just upload the file, this one. What is that? It is your what is this one? Multivariate logic regression. Logic regression 2. Okay. This one, this one, this. Chalo, you go through this and then we'll discuss very important part. I'll just rename this as 21st Okay. All right. So let us have a discussion on machine learning case study. Right. So what are the steps that we need to perform? The very first thing is step number 1 is we import the necessary libraries. Right. So we import pandas, we import numpy, we import seaborn, we import matplotlib. We import necessary machine learning libraries. So if you are using linear regression, you'll import that. If you are using logistic regression, you'll import that. And uh, as part of step number 2, you read the data by using pd.read_csv or Excel or depending upon the data type, right? Then you write down df.head, df.describe, df.tell to just check the values, right? To just check first 5 records, to check last 5 records. What is happening here? Okay, so first 5 first we just check descriptive statistics record, we check last 5 records, we check info, we check null values, right? If we have null values by using dev.isNull dot sum or isNA dot sum, if we have null values, we have to remove them, right? So either we directly drop null values, or what do we do is we impute them, right? Then next, we impute them with mean, we impute them with median, we impute them with mode. Mean and median are done for numerical columns, mode is done for categorical column. Then what do we do is, if we have redundant data types, we have to change the data types according to the condition. Let's say, suppose if you remember, we were working on case study where we were having price column, we were having reviews column, right? So price should be in numeric format, or that should be integer, but that was in object because of the dollar sign, So we have to create a lambda function, our own lambda function, which will replace the dollar with numerical data type, that is your integer, right? Then review column also has, that was object, we have to convert that into as type integer, that needs to be done. Then we have to check the sanity checks, meaning that number of reviews should be less than or equals to number of downloads, right? So only one review is possible for the application. So there might be chance that reviews are higher than download, so it is a fake review, right? You have to do the sanity checks for that, and you will put a condition, you will remove that. Then what we'll do is we'll check the outliers by using box plot, by using z-score, or by using IQR method, or by using histogram. The best ways to check the outliers is by using box plot, and we remove them by creating a function. What is that function? Def remove underscore outlier, right? Whether the data is beyond Q1 minus 1.5 times of IQR, or Q3 plus 1.5 times of IQR, we remove that outliers, right? We remove them. We identify the outlier, we remove them by simply median, imputation with median, or we remove them with upper whisker region or lower whisker region respectively. And there are several ways to remove the outliers. We do that. Then after performing outliers, we again plot the box plot, and we see that we don't have outliers. We check for the outlier again. So this outlier impact our result significantly, because that these values are not necessary for us. It will be having an impact with respect to your accuracy, with respect to your decision making, right? Then what we do is we go with the scaling part. So we have min max scaling, we have standardization, right? Min max scaling, convert your data from 0 to 1, 0 to 1, and standardization will set mean is equals to 0, and standard deviation, that is STDDEV as 1, right? Then after performing scaling, you just check the performance and you'll find that there is significant increase in the accuracy before scaling and after scaling. Then we can check for the multi-collinearity in the data by using correlation matrix, or by using heat map, or by using your VIF function, which is 1 divided by 1 minus R square. And if the VIF is greater than 5, we say that multi-collinearity exists in the data, right? Now, once we have done this, we have to remove the multi-collinearity. And how do you remove the multi-collinearity? Is by applying PCA, which we have not studied. Don't need to worry about that. We'll see each and every part about PCA. We will remove the redundant column, unnecessary columns, by creating different vector space by using eigenvalues and that kind of thing. So the logic here is higher the variance, higher is the information about the data, right? So we drop the variables which does not leads towards the giving us the important information about the data. And once we have done with this, that is data pre-processing is done, still there might be chance that we need to do we need to perform some transformations like log transformation, box cause, and something like that. Box, if you just search transformation, you'll be able to get this. Again, we have not studied this, so you don't need to worry about this. Transformation in machine learning analytics. Yeah. If you do this feature transformation, you'll see that we have different feature engineering methods, feature transformation techniques like power transformation, quantile transformation, log transformation, reciprocal transformation, square root transformation, Box Cox and Hugh Johnson. This one. So I'll just write down over here. We have Box Cox, Hugh, that's YEO Johnson. Again, we have not discussed this. Don't worry about that. We'll discuss this. And once the transformation is done, square transformation, we have log transformation, we have quantile transformation. Once this is done, what we'll do is we'll fit the model. So before fitting the model, we have to do the trend test split, right? And we have to then create a function which will we have to call the package for the ML models. There are 4 steps, right? First is object creation. So we'll create linear regression. Let's say LR is equals to the package linear regression, and we'll just call that. Second is, what is the second step of model building? You fit the model, right? So you'll write an LR dot fit. You always fit it on X-train and Y-train. Third is you use predict. So LR dot predict using Y underscore test. Sorry, X underscore test, right? We use which part to just predict? We already have done this, right? We use X test. Let me have a look at this. We use X test to predict the model. Suppose if I just check linear regression on car MPG, which we have done. Yeah. So we predict using X text. Very good. We write down y underscore parade, right? That was missing. So I'll write down y underscore parade is equals to LR dot predict. And then we'll evaluate the model by using R2 score between y test and y print that you have done. Then we can visualize the model by using plotting histogram between or plotting scatter plot to check how well the model has predicted by using y underscore parade and y underscore test. We'll just plot a scatter plot. We'll draw a regression line and we'll just check how the model has fitted. And then there are several techniques to increase the accuracy once the model is fitted that we have not completed. But to just name few, we have hyperparameter tuning, we have cross validation, and we have random search CV, we have grid search CV, something like that. And then again, we check the accuracy if it is increased or not. So we'll find that by using hyperparameter tuning, not necessarily all the times, but the accuracy increases. So that's what we have for this, right? So this is your entire, and after this, we just deploy the model. So model deployment. So that's your entire machine learning framework for the project or for any machine learning model out there. So you just make sure you are good to go with all these things. Even though we only have completed at 40% of the entire syllabus, but still I just uh, felt that this is very important part. So that's why we have discussed this. So this is your step number 1. Step number 2, we have completed. We have completed box plot, scaling, multicollinearity check. Removing the multicollinearity is not done. Transformation is not done. But we also have concluded the model fitting part, and this is remaining. So at least 60% is 60% of the data or of this particular entire machine learning framework we already have completed, right? Now it's time for your questions and answer. If you have any, you can ask. Otherwise, we'll just stop here for the day. Yes. Do you have any questions, guys? Where I have to submit the assignment. Assignment you need to submit inside this folder. Assignment submission of bike sharing assignment. I think I just have I've not given edit access. I'll just give edit access for this folder. So you can create you can upload your assignment over here, right? Simple.
Sir, I have to share the executable code and I have to write the assignment of handwriting also, right?
No, just coding. Coding you have to do, and nothing you have to write by your in your notebook, or you don't have to
Sir,
write down.
linear plus regression plus subjective plus questions, I have to attend that.
Yeah. That's what I'm saying. No, these questions you need to answer in Word format. So you copy this and write down whatever your finding is in Word format, like this, right? Yes or no?
Yes, sir. Yes, sir. Under bike aggression.
Yeah. Sorry.
1 minute, sir. 1 minute.
Okay. We'll stop here for the day. If you have any questions, you can ask.
Sir, and I have to type the code on bike sharing system, right, sir?
Sorry.
I have to type the code on bike sharing system, is it right?
See, I'll explain what you need to do in this assignment. It's very simple. You have this data. right? You have to fit a model, machine learning model, right, on this data. So for some of the column, you guys will require to do the scaling, right? Or for some of the columns, you need to change the data type. You need to find outliers. You need to check the null values, right? You can do this, check this by using your this model, the logistic regression model that we have discussed, right? You have to fit the linear regression model over this. So you can take the help of multiple linear regression model, which we have already studied, right? Right? So you can take help of this to just fit the model, but the data is different, right? So your finding, your insights, your conclusion will be different from this, but you can take help of this, no problem. Yes or no? Is it clear now what you need to do, Gopi?
I have to use the multiple linear regression on the given data set. Is it right?
Yes, exactly. Is sensitivity another name for this recall? I think we have discussed this point, right, Darshini? Just a minute. This is what we have discussed today, right? In that, we have seen the sensitivity. Sensitivity is this. Specificity is the another name for recall, because if you see recall formula, that is true positive divided by TP plus FN, TP divided by TP plus FN. Yes. So sensitivity is the another name for your recall. Correct. We have written down this. Can you see it over here? Can you see this? So recall in this context also referred to as true positive rate or sensitivity. चलो ठीक है, makes sense. We'll stop here for the day, and you guys can try, give it a try. This is 21st December, right? You have entire this month, 9 to 10 days. You can take your time, and we'll discuss in the next month. We'll discuss the assignment in the next month, right? चलो ठीक है. All right, then we'll stop here for the day. Thank you and happy learning.
Thank
Bye.
you. Thank you. Bye.
Thank you.